Good morning. Sawati Krap. It is an honor to be able to speak to you again today. And today, I'm going to take you deep on one particular topic, which is the future of energy and the disruption that is coming in energy and how it will affect or how it can affect Thailand. So you've heard a bit about me. What you don't know is that for the last 7 or 8 years, I've been heavily involved in the energy sector, really coming from an environmental standpoint. I wrote a book in 2011 about innovations in sectors like energy to overcome environmental challenges, and I now work as an investor in the energy sector as well. I'm on the board of this organization, E8, or Element 8. 8 is the carbon atom, is the eighth element, where we invest in early stage startups that hope to be the next Teslas or solar cities. And this is an attractive area because energy is a $6 trillion a year industry. It is by some measures the most valuable industry on planet Earth. But there are reasons to care about energy that go beyond the financial, because energy is also a fundamental issue of human flourishing. We are in the 21st century, and yet we have 1.2 billion people on Earth that do not have modern electricity. And when you look at this composite satellite photo from space of the Earth, those dark areas on the map are places where either no one lives or people live lacking modern energy. Now, as recently as 1990, 1/3 of Thailand did not have electricity. But of course, now electricity is universal throughout Thailand. And while many countries such as the US and Europe have peaked in their energy use and have energy use flat, in Thailand, we will see total energy use double over the coming 15 years or so. So this is an emerging energy consumer. But there's challenges with energy, because the way that we use energy also causes serious problems. The World Health Organization says that updating this, more than 6.5 million people a year die from air pollution, almost all of it from coal or from the emissions of motor vehicles. And there's this other more systemic, more global issue with energy, that the emissions of carbon that we produce accumulate in the atmosphere, and they have led to a progressive warming of our planet. 2014 was the warmest year on record on planet Earth. 2015 beat 2014, 2016 beat 2015, and 2017 just barely came in below that. Weather and climate are noisy. We will see this chart fluctuate from year to year, but over the long term, it will keep going up and up and up. And you have had a taste already in Thailand and in Bangkok of what this means. When you look at the flooding that happened here in 2011, or even more recently, you see what the future may hold. Now, we cannot say that this was because of climate change, but we do know that a warmer atmosphere makes cases of extreme rainfall more frequent and more likely. But if we continue out further, if we go out to 2070, say, or 2100, at the end of this century, we are looking at sea level rise of roughly 1 meter. And the areas in blue on this map of Bangkok are less than 1 meter above sea level. This is a threat that is global, but has a particular impact here in Thailand and here in Bangkok. The good news is that the way that we use energy is being disrupted. And this word disruption gets used a lot, but let me make it very concrete what disruption looks like. This is Peabody Coal. Peabody Coal was the largest private sector coal company in the world in 2011. And by 2015, Peabody Coal was bankrupt. Over the course of about 3 years, its stock price collapsed, and it wasn't just one company. The 8 of the largest coal companies in the world all saw a bankruptcy in that period of time. The Stowe index of stock prices of coal mining companies dropped by 90% in the span of just 3 years. Now it's bounced back. It's only 75% down now, but it's still not an asset that you wanted to have held through that time. That did not happen because we stopped using coal, but we slowed down and started reducing our coal consumption. For 150 years since the Industrial Revolution, coal consumption on planet Earth went up and up and up until in 2013 it peaked and started to decline. In 2017, it's up about 1%, but still substantially below the peaks in 2013. And when you're selling a commodity into a market where demand is dropping, the commodity price goes down, and it gets harder and harder to service the debt that you take out to build new mines, new railways, new ports. This disruption was driven by a number of things. A switch to more of a services economy, more energy efficiency, cheap natural gas in the US. But this disruption now is going global, and it's being driven overwhelmingly by the rise of clean energy. Now, energy is a fungible resource. That means people will buy the cheapest energy they can get in general. And so when we talk about clean energy or technology like wind power that's been around for centuries, really, we have to ask, will it compete with the price of an existing energy source? And in most parts of the world, you can build a fossil fuel power plant, either a coal power plant or a natural gas power plant, for around 6 US cents a kilowatt hour, about 2 baht per unit, right? That was what we would have coal here or natural gas in the US. And 40 years ago, or even 30 years ago in the US, wind power cost nearly 10 times that much. And it was only deployed because of government policies and subsidies. But that has changed because incredible innovation in the sector has brought down, this is the unsubsidized cost of 20-year wind power contracts in the US, have dropped by a factor of 15 over that time. So now in sunny parts of the world, you have incredibly cheap wind power deals being signed. Again, remember that price of about 2 baht per unit for new coal or new gas. In Morocco, we have wind power contracts signed late last year at less than 1 baht. In Brazil, we have a wind power contract signed early this year at 2/3 of a baht. In Mexico, just slightly cheaper than Brazil, 0.6 baht for 20-year unsubsidized contracts for wind power. And you see in country after country, the price of wind power is declining. That red dashed line, that is the fossil fuel parity price. And it doesn't matter where you are. Everywhere around the world, the price is coming down. Now, of course, the price is higher in places that have less wind. So I'm sad to say Southeast Asia is not the place that has the best wind. You see these red areas? They're the ones with the world's fastest winds. And you zoom in on this region, and Thailand has okay winds in some places, good enough that wind power will become competitive. Though if you go a bit away, you go to the coast, you go to Vietnam, you really do have some world-class winds that leads to the possibility of really a Southeast Asian grid that integrates the best solar and the best wind together. So wind power prices will keep coming down. They will drop by another factor of 2 as wind power scales. And that's tremendously exciting. But I want to move to what is even more exciting, which is the incredible decline in the cost of solar. In 1977, it cost $77 for 1 watt of solar modules. Today, it costs around 30 US cents. That's a 250 times reduction in what is fundamental infrastructure that powers everything else, data centers to manufacturing to transportation to the lights. This is unlike anything else. The cost of building buildings has not dropped by this much. The cost of building trains has not dropped like this. The cost of building ships has not dropped like this. Yet this disruption, this disruptive decline in price powers the entire economy. And so now we are reaching the point just in the last 2 or 3 years of crossover, where in the sunniest parts of the world, solar is simply the cheapest energy you can buy without subsidies, period. Let's come back to those numbers. Again, about 2 baht for a new coal power plant in Southeast Asia or a new natural gas power plant in the US per unit. In the US, 10 days ago, we had this deal signed. These are the lowest prices in the US now, are less than 1 baht. This is in Nevada. Warren Buffett of Berkshire Hathaway, his utility signed 4 deals for new solar power plants coming online in 2020 in Nevada, a very sunny state. Less than 1 baht, less than 3 cents, without the subsidies included. We look at the cost of 20-year power purchase agreements for solar in the US. They have dropped by a factor of 10 in the last 8 years. Now, Nevada is actually slightly sunnier than Thailand, believe it or not. So what's a good parallel for Thailand? India is a fantastic parallel for Thailand. The reason coal consumption bumped up about 1% globally in 2017 was entirely India. And in India, a new coal power plant is 3.1 rupees per kilowatt hour. Well, now we have solar bids at 2.4 rupees, 25% cheaper than coal in the only place where coal demand really is rising on a global stage, 1.25 baht. And if you look at how much sunlight India gets and how much sunlight Thailand or Vietnam or Cambodia or Laos or any of this peninsula get, it's extremely similar. If we look at the price of solar in India specifically, in the last 4 years, the cost of solar contracts in India has dropped by a factor of 4. It is a stunning decline in prices. If we go back to the Americas, in Mexico, massive energy reform has been phased in over the last few years that Thailand can learn from, and now we have less than 1 baht solar in Mexico. If we go to the Middle East, in Abu Dhabi, I love this particular photo in an oil capital of the world with solar there. I was just in Abu Dhabi, actually, about 6 weeks ago, working with the Department of Energy there. And the models that their consultants ran and we looked at said they should build solar as fast as they possibly can because every megawatt of solar deployed just saves them money, period, because of these incredibly low prices, 0.8 baht. This, by the way, was the record low price of solar for more than a year until Chile came in at a lower price early this year at about 2/3 of a baht again. These are stunning prices. This is an unsubsidized price. This is just the market price. And so again, if we look at country after country, you have the price of solar dropping much faster even than the price of wind and dropping through that red dashed line of fossil fuel parity prices. This is a revolution in the making. And so policy support plus this incredible decline in price has led to a worldwide explosion in the amount of solar. The amount of solar we have around the world deployed has gone up by a factor of 50 in the last 10 years. In fact, on a linear scale, it's even hard to imagine. If we put it on a logarithmic scale, so each tick is a doubling, it's a straight line. That means it's exponential growth. 400 gigawatts of solar deployed around the world right now and growing about 40% per year. China grew 70% in solar in 2017, though they probably won't repeat that quite this year. And this itself drives the prices down. John Hagel just talked about the experience curve, the learning curve. What that means is every doubling of the scale of solar power brings down the costs somewhere between 25 and 30%. So we had this phenomenon with solar. We have it with all exponential technologies, in fact, that at first solar was horrendously expensive. It only made sense to put solar panels on satellites you were sending into space. But then some business started to happen. Some money was reinvested in R&D, and the price of solar fell. And when the price of solar fell, new markets were found for solar. And when those new markets were tapped into, the scale of solar went up. Demand went up. And because of the learning curve, every time solar doubled in scale, the price dropped by another 25 or 30%. And it's still continuing because solar is still only 2% of global electricity. It has another 4 or 5 doublings to go. And every one of those will bring down the price again by 25 or 30%. Now, the country that we really owe a lot of this to is actually Germany, because the Germans subsidized solar 10 or 15 years ago, and Germany has about the same amount of sunlight as Alaska. Okay, Germany is not where anyone of looking to optimize their financial return would have deployed solar. But essentially, it was a gift to the world. They started the scaling of solar, which brought down the prices, and now it has come back to the German people as well, because we just had a bid in February in Germany, not a sunny place, of 1.5 baht per kilowatt hour. But Germany is nothing like here, right? The sunniest parts of the world are at that equatorial band. Though I told you more than 1 billion people don't have electricity, where do they live? They live in sub-Saharan Africa and South Asia, and in the long run, they will have the cheapest electricity on planet Earth. And now, Thailand is not the very sunniest place on Earth, but it's extremely sunny. Again, very comparable to India in the sunlight that it receives per year. And if we expand this out to cover the whole region, and we look down to Singapore, Indonesia, east of the Philippines, this is a region blessed with an enormous solar resource that is as yet still untapped due to policy choices in this region. But even so, in Thailand, the scale of solar and wind together is growing incredibly, 100x growth in the last 10 years. Still a very small percentage of the total energy mix, but growing quite rapidly. And now the government has set a target, I believe, of 30% of energy, of electricity, being renewable by 2036. IRENA has said it could be higher than that. It could be as high as 37% by 2036. And the interesting thing to me is they say this would save Thai consumers 9 billion US. There's a 300 billion baht each year, because it will be the cheapest source of energy here as well. It's not yet. Thailand is an unusually expensive market for solar. It should be much cheaper given how sunny it is, but it is changing rapidly. This is a set of charts from Bloomberg that looked at how much more expensive is solar than coal. And what they found is this, that in Thailand, in just over the last 2 years, the price gap between solar and coal has almost entirely gone away. And in the next 6 months on this pace, we should see solar contracts signed in Thailand that are below the coal parity price. And this is true not just of Thailand, by the way. This is true across Asia. You see, in China, we're basically about to reach parity. In India, as you saw, we broke through the line of parity last year. In Thailand, we're in the next 6 months. In the Philippines, we're basically there right now. Indonesia has a little ways to go. The next 18, 24 months, we'd say. Vietnam, the next 12 months. Across this region, Singapore, very similar to Thailand, actually. Across this region, solar is about to break through to be the cheapest source of new electricity, and that will change the energy mix much more than any forecast or any government plan accounts for today. So solar will keep dropping. Because of that constant doubling, the price of solar will drop by another factor of 3 over the next 10 to 15 years. Now, of course, the sun doesn't shine all the time, unfortunately, right? So what do we do when it's dark or when the wind doesn't blow? In fact, combining solar and wind is a very good idea. It's a reason that we might want to have a Southeast Asian energy grid to bring in those good winds from Vietnam and so on. But there are other options as well. One of the most effective ways you can store energy is if you have a hydro facility to pump water into it. And Thailand is actually a leader in what we call pumped hydro. Use excess electricity to pump water, and when you need electricity, you pump it back the other way, right? But that only scales so far. You have to have the right geography for that. And to get to scalable energy storage, we have to crack the technology challenges of storage. And this is now the most exciting area in clean energy. I'll show you. You all know who this guy is? Is this Tony Stark? Okay. He's the closest thing we've got. Elon is announcing the Tesla Powerwall batteries about 2 years ago, and Tesla took $1 billion in pre-orders for this battery in the first week that it was announced, before they shipped any units. And the funny thing is, this battery is actually a whole bunch of Panasonic cells in a Tesla case. So Elon is a brilliant businessman, among other things. But the point I want to make there is it was not a Tony Stark moment. It was not a sudden scientific breakthrough. It's that batteries, like solar, are an exponential technology that have been continually dropping in price 20-25% per doubling. Since 1990, the price of batteries has dropped by about a factor of 25 or 30. And forecasters, for some reason, have missed this. Here's a set of forecasts made in 2013 of what would happen to battery prices around the world. And you see the US Department of Energy forecast there would be an incredible 30% reduction in battery prices by 2048. What actually happened? Since 2010, the actual price of lithium-ion batteries has dropped by 80%. It's dropped by a factor of 5 in just the last 7 years. And it looks like by 2020, it will drop in half again. So you have to bet on the innovators and not the forecasters. Everyone has status quo bias. Everyone intuitively expects the future to look like the past or the present, and in many ways it does, but not in technology. And now batteries are still very expensive. To put electricity into a battery and pull it back out is maybe 15 or 20 US cents. 5 or 6, maybe even 7 baht, super expensive. But in markets that have a spot market, where the price of electricity behind the scenes fluctuates throughout the day, that's worth it. Because at times of peak demand, the grid will pay those amounts. Thailand does not yet have that structure. But here's an example. In South Australia, there's a very high penetration of solar and wind, and the market was not well designed. So South Australia, a very high development area, had blackouts last year. And it was sort of a national scandal, actually. And so one day, Lyndon, who was the CEO of Tesla, Elon Musk's cousin, told a reporter, Tesla can solve this problem. We can build a battery there in South Australia that will take care of this problem. And in fact, Elon committed that they could build it in 100 days, or Australia would get the battery for free. Right? And they did it. They took the bet. Australia signed the deal, and less than 100 days later, the battery was built. So then, early this year, a large coal plant in South Australia flipped a breaker, went offline. And normally, it would take at least 15 minutes, maybe half an hour, to get a natural gas plant nearby up and running, and there would have been an outage. How long do you think it took this battery to respond? A blink of an eye, 140 milliseconds. This is a digital asset. There was no blackout. That is the future of energy. And now we see that more than half of the bids for solar in the US this year have batteries included. In Chile, where I was a couple of months ago, we had a record-breaking bid of solar plus 1 hour of storage at 1 baht. In the US, we had an auction for power between 4 p.m. and 8 p.m. in Nevada, evening time. That would normally have been the domain of natural gas exclusively. And yet the company that won that bid was First Solar, using solar panels and batteries. And we see that as batteries scale, they drop in price at basically the same price as solar. Here's the price of solar dropping with scale. Here's the price of lithium-ion batteries dropping with scale. So batteries are a decade behind solar. Solar will drop by another factor of 3 in price. Batteries in the next 10, 12 years, I believe, will drop in price by another factor of 5. And that starts to bring them to the level of 1 baht, 1.5 baht to round-trip power in and out of a battery, and that starts to be disruptive to whole-scale grids. And that's just one technology. All of this is just lithium-ion batteries. Behind that, we have a dozen more energy storage technologies. Here's one. Here's a company I invested in, one of my portfolio companies. They make a flow battery. It's big, it's bulky. You would never use it in your phone. It's too heavy, it takes up too much space. But where your phone battery might be good for 1,000 charge-discharge cycles, you can do 20,000 charge-discharge cycles with this. You can build it and operate it for the same lifetime as a power plant for 30, 40 years. So there's a dozen more innovations like that, and the price of batteries will keep coming down as well. So I keep using this word cheap, right? That's a crazy word. We would never have said cheap and clean energy at the same time 5 years ago. We all knew we should go clean for a lot of reasons, but everyone assumed, as the Germans experienced, that it would be extremely expensive. But while the cost of energy fluctuates, the cost of technology does what? The cost of technology only goes down. And so now even very conservative organizations are seeing this. This is the IEA, the International Energy Agency, the world's experts on energy. The IEA is not what I would call an exponential organization. Okay? I will show you. Let's look at the IEA's forecasts for how fast will solar grow around the world. You have to read from the bottom. So at the very bottom, the light blue line, that's their 2002 forecast. They said we'll have 50 gigawatts of solar by 2030. We have 400 gigawatts by the end of 2017 in actual reality. So in 2004, they said, well, we were a little bit low in our forecast. We're going to lift our forecast. And then in 2006, they said, well, we were a little bit low in our forecast. We're going to lift our forecast. And in 2008, lift our forecast. 2009, lift our forecast. Every year, it's gone up. Every single year in the IEA's history, they have lifted their forecast for solar. And they still don't get it. They're still making linear forecasts when the growth is actually exponential. But even this organization that has been wrong on every single prediction it has ever made about solar in the history of its existence says solar will be the #1 source of electricity worldwide. It'll be 4 cents a kilowatt hour. We've already seen cheaper than that. And that rooftop solar will be unbeatable because of the avoided costs of transmission. Right? That's the IEA. And so when I come back to the government policy here, the forecast of 30%, or even the IRENA forecast of 37%, I think that's a low forecast. I think market forces can drive it to be much, much higher than this because of that declining price. And if we go back to that declining price, here's a chart I really like, actually. This is not a forecast chart. This is a historical chart from AllianceBernstein. AllianceBernstein is a private equity firm in New York City. They're not environmentalists. They are about finance and investment and making a profit purely. And they put out this chart 3 years ago now, and across the bottom, you have the price of coal, gas, and oil. And then on the right, that gray line, what is that? I think someone's child took a crayon and drew on their parents' report. Is that what happened there? I think so. That's the price of solar. And if we layer in the price of wind and the price of battery storage, this is what disruption looks like. Now, this is a 70-year chart, let's be fair. But that's what disruption looks like. This starts to look like a Kodak moment for the energy industry as we know it, right? We don't use that as a positive anymore. Now, let me be totally clear. I love Kodak, but let me also be totally clear. This transition will not be that fast. This transition will still take decades. And the reason is we build these capital assets, these power plants, these ports, these railways, we build them to operate for 30, 40, 50 years. There will be trillions of investment needed to make this transition. I wish it would be faster. Even so, the disruption is plainly happening now. Last year, China canceled, by the end of the year, more than 160 planned coal power plants. 40 of them had already started construction. Billions of investment not made, and at least 10 billion in investment just written off. Because even if solar isn't quite as cheap as we'd like in China yet, we know that it will be. So this made no sense. India, in June of last year, 1 month, canceled 14 gigawatts of solar, 8.9 billion US dollars, 300 billion baht of investments. And the answer given there for why was clear as day. The price of solar is in free fall in India. Why would we possibly build a coal plant now? And so worldwide, the pipeline of new coal plants is not quite done yet. We're still building a few, but it has dwindled to nearly nothing. Now that's new solar versus new coal. What about these coal plants we've already built, that we've already invested the capital to build them? That's much harder to disrupt, right? Well, I used to think so. But then just a few months ago, the CEO of NextEra, with a big utility in the US that operates Florida Power and Light and Miami's utilities and so on, said this. He said that by the early 2020s, it'll be cheaper for them to build solar than to operate their existing coal plants. That's crazy. That's disruption. And if we do the math, Carbon Tracker did the math, and they looked at here's the cost of operating a coal plant in the US, and here's the cost of building new solar over time. And they basically agree the early 2020s in sunny parts of the US, building new solar will be cheaper than the operational cost of an existing coal power plant. And that is a tipping point. And the same thing will happen in other parts of the world. Now, because I'm American, I often get asked about this guy. And I will just say the Donald Trump is not the king. He is only the president. And the president can't change the laws of economics. Right? In the first 4 weeks of Donald Trump's presidency, more coal plants closed in the US than in the first 4 years of Barack Obama's. Because that's the power of innovation and economic disruption. And so in the US, if we look at the last 2 years, here's the reduction in coal being used for electricity, but now solar and wind are stealing share from natural gas as well, and that's the reduction in natural gas used for electricity in the last 2 years. But now I want to come back to Thailand because I just saw a funny thing on the internet, which is I saw a minister here talking about more coal being planned in Thailand. And I understand we need electricity. Thailand needs electricity to flourish and grow, but this makes very little sense to me. It makes little sense because of the prices, and it makes little sense because Thailand is a massive coal importer already, and every dollar spent on coal is leaving the country. Right? But most of Thailand's electricity is not coal, it's natural gas. And natural gas is a bit different. 70% or so, not quite that much, but a lot of Thailand's electricity mix is natural gas. But with natural gas also, Thailand went from being an exporter to being an importer of natural gas in around 2000. And if we look at the Department of Energy's projections, they project that over the next 18 years, the production of natural gas in Thailand will fall by more than half, and the imports will climb by about a factor of 5. And those imports are very expensive gas. They're liquefied natural gas, LNG, brought in on these massive tanker ships. And if we look at the price of LNG today, that electricity is 4 baht a kilowatt hour. And the natural price of Thailand's solar is around 1 baht. That's where Thailand should be landing in the coming years with some market reforms. So this, to me, is the future of Thailand. And when someone tells you we're going to use more coal or more natural gas, ask why. Ask why you can't have a solar price like India has, and why that isn't the natural choice for the future. So all of that was about one energy type, electricity. But I want to talk briefly about the energy we use to move ourselves around as well. And that is almost entirely oil. And that is actually Thailand's biggest energy import, that big red area. And this also is being disrupted. This is a global commodity. The price spikes when even a 2% change in supply versus demand can send the price gyrating up or down by a factor of 5. But if we were talking about oil 10 years ago, we'd be talking about peak oil production. We can't get enough oil out of the ground. Oil will be $200 a barrel, $300 a barrel. We don't talk about that anymore. Now, what we see is what happened to coal happening to oil. Peak oil demand, the moment at which technology is reducing our consumption of oil. And I'm not the first to see this. In 2000, Sheikh Yamani, who was the Saudi oil minister for more than 20 years, said this to his fellow sheikhs. He said, "The Stone Age didn't end for a lack of stone. And the oil age will end with oil still in the ground." He's saying, look, people invented bronze, and bronze was better than rock. And so the rocks became worthless. And the world is going to do the same with transportation. And it's happening now with the electrification of transport. David talked about this a little bit yesterday. This is what we used to conceive of an electric vehicle as. And most disruptions come in from the low end, but Tesla did this amazing thing of coming in from the high end. They understood this virtuous cycle. They came in with a very high-end vehicle, $250,000, that funded their luxury car, which funded their more affordable sedan. And now Tesla, as Peter said, is fighting for its life. Tesla might not make it, but who cares, really? From a global standpoint, I do care. I do want Tesla to succeed. But even if Tesla went under, the shift to electric vehicles is now unstoppable, because now every auto manufacturer in the world is working on electric vehicles with longer ranges at lower costs. Volkswagen announced about a month ago they would spend $25 billion just to secure battery supplies for their vehicles over the next few years. GM has said their future is all electric, 20 new electric models coming in the next 4 to 5 years. And the total volume of electric vehicles is still tiny. There's still about 1 out of every 300 vehicles. 1 billion cars on the road, only 3 million electric. But the growth rate is astounding. It took 20 years to sell the first million electric cars. It took 18 months to sell the second million. It took 8 months to sell the third million. And it's going to take about 4 months, 5 months to sell the fourth million. 58% annual growth. And again, the forecasters missed it. Here's the US Department of Energy in 2015 saying how many electric vehicles will we have with a 100-mile range, that's a blue line, or a 200-mile range, that's the red line. You might not be able to read it, it's so low. Let me help you out. They said 20,000 electric vehicles in the US total by 2040 with a 200-mile range. How many Model 3s has Tesla taken pre-orders for? Right? About 500,000, one manufacturer. Right? The forecasters have status quo bias, and the future is not like the past. In fact, we have this virtuous cycle. The most expensive part of an electric vehicle is what? Battery. As we sell more EVs, we sell more batteries. Battery prices do what? They go down. That means the whole electric vehicle cost goes down, and that means electric vehicle sales do what? They go up. That virtuous cycle spins and spins and spins. And in fact, on this trajectory, electric vehicles are on pace in the next decade to be the cheapest vehicles. You could have a car like the Model 3, a 5-seater car that accelerates like a Porsche with self-driving features cheaper than a 2-seater smart car. And if that sounds absurd, consider that this is the entire engine and drivetrain of an electric vehicle. And this is the engine and drivetrain of an internal combustion vehicle. Right? The only reason EVs are expensive, 2 reasons. 1, batteries are still expensive. That's changing. And 2, they're made in small volume. But once they're made in volume, like internal combustion engines, there's every reason to believe this will be cheaper than this. And then they will combine with 2 other trends, with self-driving vehicles, because self-driving, which every manufacturer is going after, will create more and more reasons to use services like Grab or Uber. They will shift us in that direction as it becomes more and more convenient. And vehicle services where you pay by the kilometer create a direct comparison in price per kilometer between electric and gasoline. And electric vehicles are more expensive up front, but overall their cost per kilometer is already lower than internal combustion vehicles. Right? Here's a study from London. 4-year cost. That's the internal combustion vehicle. That big orange block is the cost of gasoline. And then 4-year cost, electric. That's the cost. It costs more up front, the blue bar, but the energy cost is so much lower. And in 10 years, the blue bar will have shrunk. And the per kilometer cost in an electric vehicle could be 1/2 of what it is in an internal combustion vehicle. So when you call that Grab or that Uber or that Lyft, what are you going to call? The market will win out. And so these 3 trends accelerate each other, have a virtuous cycle with one another. And so you see that now the forecasters are starting to do the same thing the IEA did with solar. Every single year, every forecaster in mobility lifts their forecast of electric vehicles. Here's 4 different forecasters on one chart. Here's how they've changed in the last 3 years. BP or Exxon tripled their forecast. BP more than doubled their forecast. OPEC between 2015 and 2017 increased their forecast for electric vehicles by a factor of 5. That's what's happening, and they're still trying to catch up. And if we look at the growth rate, in about 2023, electric vehicles will account for 100% of the growth in vehicle sales, and we will reach peak gasoline car sales. And following on the heels of that will be what we've talked about of peak oil demand. When will that happen? Well, here's the IEA. The IEA says basically never. Out to 2040, still more oil being used. Here's Bloomberg. Bloomberg says it could happen as soon as 2020. I think that's overly aggressive. What do the oil majors say? Total, the French supergiant, says by 2030, peak oil demand will be here. Statoil, now Equinor, says in the 2020s, peak oil demand will be here. Shell, I'm on the advisory board for Shell's New Energies Group. They say in the next 5 to 15 years, peak oil demand will be here. And this will change the world. It will disrupt nations who depend upon this for revenue, and it will save nations like Thailand billions of baht that they don't have to send, because you can now power your transport with solar and wind produced locally rather than sending those dollars abroad. I'm going to close with some ideas of how to take action in this sort of disrupted marketplace. The Chinese character for crisis is both danger and opportunity, and we have both. We're not out of the woods yet in climate change. The pace at which we have to reduce our emissions is unprecedented. We have to cut global emissions by about 6% per year. We've never done that. We have to hope that solar and wind and EVs and batteries keep going at their exponential pace with no hiccups, and then add some other things on top of that. We don't know. And to do that, we have to leave a lot of oil, coal, and gas in the ground. How much? Citi says around 100 trillion US dollars worth of assets can't be used to stay under 2 degrees Celsius. That's an incredible number, right? That is disruption. Now, in this disruption, there are winners and there are losers. So here are a set of 6 pieces of advice that I have. First, this is technical terms here. Be careful of highly volatile assets. The price of oil is doing well right now, but if you have exposure to oil or traditional automotive or coal, be very careful, because these things will not be high-priced forever. Second, you can use solar in Thailand today to reduce your costs. You can't yet sell it back to the grid. This is a factory in Ratchaburi using solar on the rooftop to reduce the amount of energy they have to buy. And especially if more LNG comes in, the price of electricity will go up. So it makes more and more and more sense to do this. 3, and this is advice for Thailand as a nation, get energy independent. There is no need to send billions, hundreds of billions of baht abroad every year. Half of Thailand's energy is imported. On current plan, by 2030s, that would be 3/4 of Thailand's energy would be imported. That is baht being lost from Thailand. How much? About 20%, about 20 billion USD, or 600 billion baht, is what Thailand is sending abroad to import oil and gas and coal, almost all of which could be preserved right here. 4, and this might be the most important of all of these, open the market. The market is a technology. Use the market. You see, this is the price of solar, wind, and so on dropping. Those orange dots are where there were open, competitive auctions. And Thailand is heading in that direction slowly, but it's still not an open auction market. Look to the example set by another middle-income country, Mexico, that went through massive reforms, opened up the market, and saw the price of solar plummet. Or Chile, where the price of solar plummeted, and that was passed on to customers as lower price of electricity. Use market signals to signal to consumers that the price of energy is different at different times of the day, and you will get the right behavior back. Look for these reverse auctions to get you lower and lower prices. And then take a page from Singapore's book. Singapore, with very similar sunshine but so little land, knows it must have solar on all of these surfaces if it can. So Singapore lets people who put solar on their buildings sell it back to the grid, which Thailand does not yet do, net metering. And that is a vital market reform. 5, when I talk to businesses, I tell them, be flexible. Take your manufacturing, take your energy-intensive parts of your business to where the sun and the wind are best. But when I talk to you here in Thailand, I say, use your sun as a strategic asset. Thailand has some of the best sunshine in the world and a highly trained, highly educated workforce, and that should make it a more and more attractive place to move manufacturing and energy-intensive businesses. And 6, finally, invest in the future. The world will spend 300 billion US dollars this year deploying clean energy, and that is a massive, massive investment opportunity, and you're welcome to come and get a few of the thoughts from me on the sorts of things that I invest in. And I will close finally on a philosophical note. I went to the University of Illinois, Urbana-Champaign. That computer is ILLIAC. It was the world's second digital computer. It was larger than this room. It weighed tens of tons. It drew tens of thousands of watts of electricity. Right? And on the left is an obsolete piece of technology, an iPhone 6. And it weighs tens of grams, draws milliwatts of electricity, and it's billions of times more powerful than ILLIAC. If you wanted to build something as powerful as my phone using ILLIAC technology, it would have a footprint larger than Bangkok. It would be kilometers tall. It would draw more electricity than the whole of Southeast Asia, and it still couldn't Snapchat or play Angry Birds or take selfies. So how is it possible that this thing is so much smaller, uses so much less energy, and is yet so much more powerful? My answer is this. This device is not made of matter. This is not made of glass or silicon, rare earth metals. This is made of information. It's made of accumulated scientific discoveries, engineering discoveries, accumulated software innovations. And information has radically different economics than matter. Because I could drop this phone and break it, but we have the knowledge to build all the phones we want. You can never chip an idea. I could have this phone stolen, or I could give one of you my phone, and I wouldn't have my phone anymore. But if I give you an idea, we all have the idea. And if you give me an idea back, we're all richer for it. And the right idea, the right innovation can reduce the need for any resource, can substitute for land or labor or energy or capital, can multiply the value of any physical resource that you have. And this, our store of knowledge, is the one natural resource that is continually growing over time and multiplying the worth of everything else we have. And that is why I am an optimist. Thank you very much.